Alright, welcome back. So looking at problem number 15, this will be the last one we work today. But looking over the problem, we're just going to go through and identify some stuff. I'm going to draw on the graph. If I didn't tell you to add arrows to the ends, make sure you add arrows to the ends. But looking at the domain, really the domain is very simple. Anytime you have arrows on the ends of these lines, that just simply means the domain is going to continue to go from negative infinity as far wide as positive infinity. Because this graph in reality is going to continue to get wider and wider and wider, which means the domain is going to go from negative infinity to positive infinity. Now the range is a little bit different. The range is going to be going from lowest to highest. So when we look at the lowest possible point this can reach, we can see that this is going to be at 1, 2, 3, negative 4. So the lowest it can go to is negative 4, but the highest, since it has these arrows on the end here, indicates that the highest it can go to is positive infinity. So the way we write the range, since it's equal to negative 4, is bracket, which means equal to, negative 4, comma, infinity. And then that just means that it starts lowest at negative 4, and then the highest it can reach is positive infinity. Now, for positive and negative intervals, the way I look at that is I take my furthest it can go to the left, furthest it can go to the right, and then I focus in on these X-intercepts, which here are going to be located at negative 2 and at positive 2. And then I just look at those sections of the graph. So if I focus on negative infinity to negative 2, I notice that from this point to this point, the line is going to be above, notice how it's above here, the x-axis. So that means that it's positive. So that says negative infinity to negative 2 is going to be above or positive on the interval. Now, if I continue that same thinking and I notice these values go down after that underneath the x-axis, that's going to be from negative 2 to positive 2. So negative is going to be negative 2 all the way out to positive 2. Then, here at positive 2, we're going to cross back over, and if you notice, we continue to go up and to the right from positive 2 all the way to infinity, and those values are above, meaning that that's going to be a positive interval. So that's going to be from 2 to infinity. So keep in mind that you will have two intervals that are either positive or negative when dealing with quadratics. And like I said, identifying the X-intercepts is what's going to help you identify that information. Alright, so I cleaned my graph up just a little bit so we can identify some more information. So next is going to be the vertex. Now keep in mind the vertex is going to be this lowest point. So that one's pretty easy to identify. We know that the vertex here is going to be 0, negative 4. So writing the vertex down is very simple, 0, negative 4. Keep in mind if they ask for the axis of symmetry, the axis of symmetry is always the 0 value, or the x value, which here is 0 for the vertex. So you could write x equals 0 if you wanted to identify the axis of symmetry. Oh, we do have that, so let's go ahead and write that down. So x equals 0. Alright, factored form. The factored form, if we recall, factored form and intercept form are both y equals a, parentheses x minus q, or x minus p, times x minus q. So all we really need here, we're going to, with this graph, we're going to say, you can kind of look at your points and see, but here we're going to know that a is equal to 1. So all we're going to focus on for this problem is going to be the x-intercepts. So here you notice that you have an x-intercept at negative 2 and an x-intercept at positive 2. So since we have a negative 2, we're just going to flip that around and say that it's positive 2 when we put it back in the parentheses, and then negative 2 whenever we flip the positive 2 over. So to write that in factored form, that's going to be our answer. So that's going to be y equals x plus 2 and x minus 2. So that's going to be your factored form. Interesting question there. You may want to make sure you note that. And like I said, that might end up being a question on the test tomorrow. So very, very interesting question. All right, interval of increase and decrease. These are probably my favorite because all you got to pay attention to is the vertex. Now, here the vertex is located on the x value of 0, which means that's going to be our breaking point. So if you pay attention to this line, if we start over here on the left, you'll notice that the left is going to go, or the line's going to go down or decrease starting at negative infinity and going all the way to this point, which is located on the x values at 0. So interval of decrease, since this is going down, is going to be from negative infinity all the way out to 0. Now, once I get to 0, I can then see that it changes and it starts going up, 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 increasing, right? So if it's increasing, that's going to start increasing here at 0, and then it's going to continue to increase, all the way out to infinity. So that's going to be starting at 0, and it's going to continue all the way out to infinity. Now, end behavior is very simple as well. With end behavior on quadratics, all you really need to do is pay attention to whether the graph is opening up or down. Now, in this problem, we can obviously tell it's opening up because the lines are pointing up. All right? But anytime that it's opening up, both end behaviors are going to be positive infinity. If it's opening down, they're both going to be negative infinity. So here, as we move to the left, all right, as we go to the left, the graph is going to go up. And it's going to go up to infinity. As we move to the right, it's also going to go up. And you can see how it goes up to infinity as well. So when we write our answers in, we want to write infinity and infinity, meaning that this graph is going upward. All right, so I think that covers everything except rate of change. So let me clear off just a little bit of my board here so that we have some room to work and discuss this. All right, so for rate of change, down here at the bottom, rate of change, we're going to be looking at the interval -3 to 0. Now what that means is that x is equal to -3, and x is also equal to 0. So what we're looking for here are 2 points where the x value in one point is -3, and then the x value in the other is 0. So what we're going to need to do, we'll kind of clean up this graph just a little bit so that you can see this a little better. But what we're going to need to do is we're going to need to look at our graph and then determine where those points are located. So let's start with -3. So if we start with -3, all we need to do here is just go 1, 2, 3, and then find where the line is located. So if we follow this up, and we want to follow it up as straight as possible, it's hard to kind of tell because you can't, like I said, this one's a little bit difficult to tell. Tomorrow's graph would be a lot easier to tell, but when you look at this one, you can see that it kind of crosses somewhere right here. So if we follow that over to our y-axis, we can see that that's going to be at -3, 1, 2, 3, 4. Okay, so that's going to be -3, 4 as the point that's going to be at x equals -3. Now for 0, it's a lot easier to tell on this graph because here at 0, we just got to follow it down. And when we follow it down, we find the point is obviously at -4. So this makes for a very interesting rate of change. So let's solve it and see what we get. Now, to find the rate of change, remember we're going to use the formula y2 minus y1 over x2 minus x1. That'll be on your formula sheet, so no need to memorize that. So here we've got x1, y1, x2, y2. And then all we need to do is just substitute in our values. So y2 here is going to be -4. Y1 is going to be +4. X2 is going to be 0. And then X1 is going to be -3. So when you solve this, -4 minus 4 is going to give us -8. And then 0 minus -3 is going to give us +3. Now you could leave your answer as -8 over 3, or you could simplify it down. So I would simplify this down to a decimal and say it's -2 should be 2/3, which is 6 repeating. So for the rate of change, we would just simply write down either -8/3, or you could write down -2.6 repeating. Alright, so hopefully that answers any questions that you have over this information. If you have anything else that you need to ask me, feel free to email me. Usually I'll probably be in bed by like 10 o'clock. So anything after 10 o'clock I'll answer in the morning, unless I wake up in the middle of the night. But outside of that, if you have any questions, just feel free to email me. Make sure you write this down, because the thing is, I'll be taking this up as a review grade tomorrow. I didn't tell you that in class, but I wanted to see who would actually go in and watch the video. So make sure you write this stuff down. And if you write it down, you write everything down from this, turn in the review, I'll give you 100 on the review. And then those people that did not do this information, did not do the review, they will get the grade that they deserve. So make sure you write this stuff down and have it worked out and study it. And then when you come to class tomorrow, get your review out. You should know to turn it in. So get your review out. We'll turn it in first thing and then begin our test. Remember, the test is 25 questions, all multiple choice. 10 of the questions are on problem number 15. So make sure you pay close attention to problem number 15 and know how to find each and every part. All right. Good luck tomorrow, and I look forward to seeing you guys tomorrow. Have a great evening.